All
Okay.
right, so this is Julio Faerman. He's from Brazil. He's a technical evangelist at Amazon Web Services, and today he's going to be talking about using Jekyll on the AWS platform. All right, you're
All
good to
right.
go. I'll
Thank
just
you.
switch it over to you.
Let me share my screen. So now I hope you can see my screen.
Yep, you're looking good.
Perfect. So I'll talk to you guys today about Jekyll on AWS and a few services we have to help you publish and build your Jekyll websites. And why, in first place, run Jekyll on AWS? Well, as you may have, some of you may have found, there's no such thing as unlimited and free resources, no free lunch. So at AWS, we do have something that's quite that. That's the AWS free tier. So you can run your Jekyll website for free at AWS. That's something most people overlook. Of course, there are some limitations to that, and I'll talk about those in a couple minutes. But you can easily scale to whatever level of infrastructure you have with our services. And the first service that I'm going to talk about is S3, and we'll go quite deep on that. That's our most important service for storage and publication of web content. Or you can go and do it yourself with Amazon EC2 if you have some peculiar requirements that S3 may not comply. And other than that, we can use our CDN, Amazon CloudFront, to optimize distribution. There are some options for continuous delivery and even for using Jekyll as a more in-depth application platform. So that's quite what I'm going to talk to you guys today. So first, some people go at building a Jekyll website as they would with a regular web application. And we have the usual web servers, virtual private storage, and load balancing and DNS, and that's quite okay. But we have a simpler option, that's the managed service called Amazon S3, and that's quite important for static websites because S3 provides a very high level of durability. We'd say designed for 11 nines. This is because every object, every file you put on S3 is automatically replicated to at least 3 different data centers entirely. So this provides a very high level of durability and availability to your content, and also a very high throughput if you are serving media, images, videos, and such other types of content in your blog. You may find that the throughput of S3 may be extremely desirable. And it is very full-featured. There is a feature exactly named static website hosting that lets you set index and error pages and publish your website directly to your DNS CNAME. And you can also have security if all your content is not public and you want to restrict who has access to what. S3 can help with that. We have versioning, so if you delete or update something by accident, you can revert to previous actions. Events to bind updates or deletes to your application that may trigger your deployment or may trigger some web service. There are a couple ways to bind S3 events to other places. And another important feature is lifecycle that lets you change the storage type of your bucket. Okay, so this means that if you want to archive some content permanently in Glacier, or even delete content automatically after expired, that's available too, and that's what S3 can do. So, and how do we go about using S3? Well, you can create your Jekyll website as you normally would, and then you can go to the service console and update those files right from the web console. And this is one way to go about this, but if you're doing constant updates, and a more convenient way would probably be to use the command line tools. And this is something a bit subtle but important to note, that AWS is just a set of web services, and the web client, the web console, or the command line tools, or the SDKs are just clients, different clients to the same web service. So you can use the AWS S3 MB command to make a bucket, or the AWS S3 sync to synchronize a local directory, such as your generated site, to your published bucket. Then I just updated my website configuration, saying that this bucket will have an index document named index.html, so that when I request directly from the bucket, that is going to be the response by default. And another important aspect is the policy of your bucket. This meaning the default credential, the default access that people will get. And this is a bit of a specialized language of AWS for declaring permissions. If you never played with AWS before, this may sound a bit strange, but it's quite simple. I'm just saying that any principal, everyone will be allowed to get objects from this bucket. So this meaning that this bucket will be public, and this is the same language that you would use to restrict access to parts of your bucket, or just let people upload to certain paths of your bucket. And after that, you're all set. And if you make an HTTP request to your bucket website URL, you get the usual Jekyll response, as you probably expect. But that's not where the fun stops. Another very important part, especially for larger websites, is to optimize content distribution, and we have CloudFront for that. CloudFront is a CDN, and it runs in a very different part of AWS global infrastructure. The yellow dots that you see on these maps are the AWS regions, and we have those all around the world, but we have even more points of presence of our CDN, so you can serve your cached static content directly from these blue locations and have lower latency and a better performance for your website. And you can even go very specific about how CloudFront behaves relating to our content. One particularly important configuration is the caching information. What do you allow to be cached, and for how long those things are going to be cached? This is very dependent on your cache configuration. You can set a minimum time to leave for every object, but if you don't set a minimum time to leave, CloudFront will respect your HTTP cache headers. And even in S3, you have control of those headers as you would have on a regular HTTP application. And by object, you can set your cache control headers, and they will be respected by CloudFront. And CloudFront also helps a lot in serving private content. So you can use S3 and CloudFront to create signed URLs and signed cookies that are going to be valid only for the lifetime that they need, and only match with the signature that you ship to your client, and that may help to publish private content. So this is the full documentation page if you'd like to look that up later. And if this sounds a bit too complicated and you never created S3 buckets and CloudFront distributions, there is an awesome open source project on GitHub called S3 Website that automates every step that I talked about earlier for you. So if you want a simpler way of publishing static websites to AWS, that's a very good reference. And one thing that our customers and I myself use a lot is continuous delivery to AWS. So I usually set a pipeline like this where people writing content pushes directly to the content repositories. that can usually a Git repository, such as GitHub or our own AWS code commit. And every time a change happens, an SNS topic is notified. So SNS is our service for notifications. And then after being notified, that's usually put in a SQS queue, so it's durable and the message stays there, that notification is stored until it's consumed by whoever is updating the content. I usually do that using the AWS command line interface and use that to push to S3, as I've shown you in the previous example. And why not push directly to the SQS queue? Well, you could do that, but I like to have other notifications as well, especially for debugging and monitoring. You can use the topic to also ship the notification to a web service or to your email. And a common question is about the costs of running the AWS CLI on EC2 instance, for example. And the way to go around that is to have an auto-scaling group. This is the logic, the component that AWS uses to scale automatically. And it's usually used to increase the capacity of your website, but in this case, it's very common that you have an auto-scaling group that is usually at its minimum size 0 and has at most one instance that is started when you have a message pending on this queue, and you can bind that with a CloudWatch alarm. So the full process would be trigger an update, the update triggers an SNS topic, the SNS topic delivers the message to the queue, which is consumed or by the instance that may be brought to life by an auto-scaling event triggered by alarm, and that goes to S3. It may sound a bit complicated, but I'll show you that's quite simple. This is the script that I use to pull messages from an SQS queue. So it's basically use the receive message command to get the messages pending, fetch everything from GitHub, build and publish, and delete the message from the queue. And the build and publish is just Jekyll build and an S3 sync. So it's pretty straightforward to automate your Jekyll publication with AWS. This is one way to go about it. There's a couple others, but I find that quite simple. And let me show you how that would work. I have a small website here. This is my next blog about biking, and I have not a very exciting index, but if I edit this file and change my background to blue, for example, and commit my changes, you see that this repository has got this Amazon SNS webhook. So here is where I specify which Amazon SNS topic will be triggered. This is the topic that will receive the message, pass the message to an SQS queue. This will be consumed my sync box that is running on my account, and it will update the website. I hope that may have already happened, and you will see my new blue background. And also, I like to share my writings with non-hackers. This is, for example, is a bicycle-related website. So most people won't be, I don't want to spend too much time teaching them to use Git. I'd rather have them teaching me about riding a fixed gear bike. And so I use sync clients to share with other people. So in this case, it would be a very similar approach, but also, other than listening for SQS, you can use your system scheduler to generate the website regularly, or even using Facebook's Watchman to react to changes in this set of files. And this is what I do in this case. So just for example, I have here in my Dropbox shared folder this very example. Let me take this HTML and say that now I want it to be red and save, and it will trigger the very same build scripts. And I hope that by the time we're here, my background's already red. So, and of course, that is a very, very simple website. Please don't judge my web design skills, but you can see that anything is buildable with your plugins, your setup, everything you need from Jekyll. And we have recently launched a service called AWS Lambda that allows for serverless computation, and a lot of people is interested, particularly in running and building Jekyll websites with that, and that is certainly doable. There are basically two ways to go around that: using the shell from the container that AWS Lambda launches on your behalf, or starting from the JVM with JRuby. You can possibly build a Jekyll website from that. But a very important aspect to know when you're building with AWS Lambda is that Lambda is a container-based system that will boot a new container when your instance is activated, when you receive an event, and that container may be reused for a while, but then it may go away and be replaced by another container. So it is a serverless, stateless execution engine, and that means that the first time your site builds on that engine, on that container, it may take more. And so if you have a very large static website, you may want to have a separate storage on a network file system, such as Elastic File System, and connect that to your container instead of downloading the whole data every time or something like that. So that's something to be aware. And another very important aspect is that we have SDKs for popular languages, and that it's no different for the JavaScript in the browser, meaning that you can access the S3 APIs and the Amazon Web Services APIs directly from JavaScript in the browser, as you would on the command line interface or in the web console browser, on the browser. And this allows Jekyll to become a very powerful platform for serverless applications. So let me talk to you guys a minute about the services that you may use for that. So Amazon Cognito is our service for identity and data synchronization. So if you want your user to be able to log in with Facebook, Amazon signing, Google, Twitter, and even your custom authentication provider, you can do it with Amazon Cognito. And Amazon Cognito also synchronizes data from your identities using mobile devices and web clients, so you can change from one to another and your application keeps the same state. We have Amazon API Gateway that lets you publish web APIs, and that is particularly useful if you want to extend your Jekyll website with server computed databases or resources such as comments, chat, anything that may security, anything that require some kind of computation that you don't want to change from the static paradigm, but you need some kind of computation. You can use an API for that. I'm sure you know there are several plugins for that Jekyll that use this remote API approach, so you can add live data to your static websites. And a good way to go about this is having your API published on API Gateway, calling functions on AWS Lambda so that you don't manage infrastructure yourself and let your code running on AWS Lambda do the work. And we have serverless databases such as Amazon DynamoDB that can store your data all without you having to manage a single server. And we talked about static hosting on Amazon S3. Amazon Kinesis is for data ingestion at scale. If you're listening to too much data from the outside world, and that can trigger several actions on your backend, such as workflows. At our workflow management service, that's SWF, you can get use Amazon machine learning from your data, from your Jekyll data, for example, that may be contributed by users to make prediction systems and all sorts of applications. You can combine that to Amazon IoT, AWS IoT, if you're running devices on the Internet of Things, or transcoding video. Well, those are just a couple of examples of all backend services that Amazon Web Services provides could easily be into those slides. Those are the ones I think might be most useful for building a very compelling and rich serverless application using a static front end served from Jekyll. And in my experience, that is a much simpler way of going about writing client applications. And I'm sure you guys can think a lot of use cases for that. And if you're interested about this kind of architecture and where this may go, please tweet Jekyll on AWS. I'll be checking that out, and I would be happy to talk more in depth about this in my next Jekyll talk. Again, we have a free tier, and all the services I mentioned today, including SNS, SQS, CloudFront, S3, EC2, the whole thing can be built for free within the free tier constraints. Some resources expire after 12 months, so you get a year to set things up, make proofs of concept, and even if you ever need help with running your Jekyll website on AWS, feel free to give me a shout. And this talk wouldn't be possible with the great work from my peers, Jim Tran and others that built this white paper, Building Static Websites on AWS. This published in December 2015 with most of the things I talked about today. And I strongly recommend that you take a look at that white paper. And other than that, the slides of this talk will be tweeted. I'll tweet the link right after. And thank you very much. I really love Jekyll for a while, and it's a great pleasure to speak to you guys today. Thank you very much.
Awesome, thank you very much. Yeah, that was great. So we've got a couple of questions here.
Sure.
So the first question is from Oliver Pattinson, and he's saying there's a lot of ways of deploying a website to Amazon S3. What's your favorite way and why?
Well, I usually do it directly from the command line, as I've shown you, and this is because it's very, very simple, and you can bind that to anything that can run a shell script. So just to show you guys again, and this is my build and publish script. So see, it's just a Jekyll build and an AWS S3 sync. So this is quite easy to plug into, to run from your local environment or to run from your favorite continuous integration server, but definitely look at the AWS S3 CLI for a command line interface. Particularly the sync command is all you need to publish to S3.
Cool. Next question is, with Amazon Lambda, you mentioned one of the limitations, one of the things you have to solve is actually getting the files onto Lambda, which you can do by mounting a storage. Yeah, I've forgotten what it's called on AWS. Yeah, storage container.
Yes.
What other limitations do you have on Lambda?
Well, actually the lifetime of a container is limited to 5 minutes, I believe, so your build would need to run for at most that.
Yes.
But Lambda gives you resources based on the memory that you provision. So if you provision a lot of memory, it will provision a lot of CPU, and you can build a lot of Jekyll in 5 minutes. So that is not what the most alarming part. The really problematic thing is state management. So you may have your container up for long or just for the time of your build, and as it's not running very often, I believe, it will probably be a new container, and if you have a big website, it's probably better to attach a network storage. And we have services for most cases, you can just go with S3 and do an S3 sync back to your instance, and that's quite fast because it's on the same network and you have no extra cost in this communication. But if you need if you can't copy this lot of data that you have on your static website, if that may be your case, look at Elastic File System. That is a network, Elastic network file share that you can mount through NFS and just keep the same state all the time.
Awesome. Okay, that's all the questions we have time for. Yeah, thank you very much for speaking today.
Thank you. See you next.